All right, for the amazing class on this Wednesday, I think it is necessary to make a video for you to learn more details. So in the class on Monday, we talked about the first 3 steps for the hypothesis test. Let's review a little bit. All right, so we say we totally have 4 steps for this hypothesis testing process, and I say the first step is called the state the hypothesis. So when we state the hypothesis, we need to make sure they are in a pair, right? One is called the null hypothesis, the other one is called the alternative hypothesis. And since we are reviewing the hypothesis test for one population mean, so then of course we are testing about the population mean mu, not X bar. And then for the null hypothesis, it is about the equality, right? So then we test about mu equals to mu 0, and alternative hypothesis, we have 3 options. We can test about mu less than the claimed value, or the mu larger than the claimed value, or I don't care, it is less than or larger than, I just care about whether they are different. All right, and then here mu 0 is called our claimed value or hypothesized value, and for the alternative hypothesis, right, so these 3 options, if we are testing about the population mean is less than the claimed value, then we call this hypothesis is a left tail hypothesis. If we are testing about the mu larger than mu 0, then we call this is a right tail hypothesis. And for the last one, we call it is two-tailed hypothesis. All right, okay, so then after the step 1, we also talked about the step 2, right? So we start our hypothesis testing process, and then we need to calculate our test statistics by a formula, right? So then actually we talked about 2 formulas. One is the z-test statistics, x bar minus mu 0 and sigma over square root of n. And here we need to make sure that the population standard deviation sigma is given, or we know it. The other way, if we don't know the population standard deviation, then in the formula, everything will be the same, but we will replace the sigma by the sample standard deviation s, and at the same time, we don't have the z-test statistics anymore. We'll have a t-test statistics. All right, okay, and then we say before you can have a formula, actually this formula comes from our z-score formula. All right, so actually here we talked about a story or an idea for the hypothesis test. We say this formula comes from our z-score formula, which x bar minus mu sigma over square root of n, right? And then we say the idea is we want to get a z-score, but the problem is we don't know the population mean mu. Then we need to have some value for this population mean mu. And since we are testing about the mu 0, which is our claimed value in our hypothesis, right? So then we want to first assume the null hypothesis is true, which that means the mu equals to our mu 0. All right, so then when we assume the null hypothesis is true, that means we can replace the mu by mu 0, so that I can know every value in this formula, right? So then based on this z, we can find the corresponding probability. And actually this probability is how large chance the null hypothesis can be true, right? So then we say if this probability is small, that means the null hypothesis can't be true. Cannot be true. That is why we want to reject the null hypothesis at the end. The other way, we say if this probability is not that small, let's say it's big, then that means the null hypothesis is likely to be true, right? And then that means at the end we say we fail to reject the null hypothesis. All right, so then here we talked about the idea of the hypothesis testing. All right, then let's come back, right? So we have these two formulas, but we know this formula comes from the z-score formula. So then actually we do need to check assumptions first, right? You say if any of these assumptions are not satisfied, then of course we don't know whether it follows a normal distribution or not, then we cannot have this z-score formula anymore. So then everything else will be meaningless. So this step is very, very necessary and very, very important. So then we say we do need to check the two assumptions, independence assumption and normality assumption, right? And then for independence assumption, we do need to check the two things in details. This is also my requirement in your assignment. I need you to show me that you understand what do you need to check for each assumption. All right, so then for independence assumption, we need to check the first one, which is easy, right? So we need to make sure the sample is randomly selected. And the other one we call the 10% condition, but you cannot just say the 10% condition is checked. You do need to show me that n is less than 10% of the population size. We call this as the 10% condition. All right, but you do need to show me the details why this 10% condition is checked. All right, and then for normality assumption, easy, right? So then actually we just need to make sure n is larger than 30 so that we can apply the central limit theorem. All right, okay, so then after this step, we say for step 2, we just calculate, right? We just want to calculate a score or a value. Here, this value is called test statistics. Can be t, can be z, can be a t. And then next step, we want to continue to step 3, right? So now we have either a z or t test statistics. Then we want to continue to use this test statistics to find the corresponding p-value, right? So of course, there are many ways to use the test statistics to find the p-value, either by your calculator or by any software. But to be consistent, because not all of you have the graph calculator, all right, so then in this course, we'll just use the table to find the p-value. But if you can find other ways to find the p-value, is totally okay. All right, okay, so now let's just assume the test statistics is already calculated out based on these two formulas. All right, and then last class we talked about the two cases. right? So we say if we have a z-test statistics, then how to find the p-value? There are 3 cases we need to consider, right? So now it's time for us to look at the alternative hypothesis, which is mu less than mu 0, or mu is greater than mu 0, or mu is not equals to mu 0, right? So then the way to find the p-value depends on different cases. All right, so then for the first case, when we have the, we call this is what? This is the left tail hypothesis. So if we have the left tail hypothesis, then the p-value will be the left tail, right? So then we will have our z-test statistics first from the previous step, right? And then based on this z, the corresponding left tail will be my p-value, right? So then actually what you do, you use your z-test statistics, go to the table, right? Go to the, let's say, z table, right? And then find the corresponding probability to the left. Is this your p-value? Remember, whatever you found from the z table is already probability to the left, which is the one we look for here, right? So then actually whatever you found it will be your p-value for this left tail hypothesis. All right, and then next case, if your alternative hypothesis is mu larger than mu 0, then we say we'll have a z here, right? So we call this is small space here. All right, so it's z-test statistics, and since we call this is the right tail hypothesis, we care about the probability to the right. So then it is the right tail hypothesis here, and then we call this part as my p-value. And then what we do, exactly the same procedure, right? So we use the z-test statistics, go to the z table, and find the probability to the left. All right, is that all? Do we stop here? We say from the z table, we always can find the probability to the left of your z, but remember the p-value now, we look for the probability to the right, so then what we do? 1 minus whatever you got from the left, so that we have the tail to the right. All right, and then the last case, we say it is called the two-tailed hypothesis. Why we call it two-tailed? We say it doesn't matter the mu is less than mu 0 or mu larger than mu 0. Both of these two are considered as they are not equal. They are not equal to each other, right? So that means both of these two cases will be considered. Both the left tail or the right tail will be considered, right? So then the p-value will be this tail plus this tail. That will be the p-value here. All right, but the good thing is, remember the normal distribution is symmetric about 0, standard normal distribution, right? So then that means you can just find one tail, double it, or you can find the right tail, double it. Depends on what? Depends on you want to find the left tail first, or you want to find this right tail first. All right. So then we say for this case, we may consider 2 different cases. One case is if your z is negative, That means after calculation from the last step, you have a negative value for the z-test statistics. Then you want to find this tail first and then double it, right? So then whatever you got, so in this case, your z-test statistics is negative. Then you want to use this z-test statistics, go to the table, find the probability to the left directly, which is this part, right? And then the p-value will be 2 times whatever you found here, right? And then the other case is your z-test statistics is a positive value, which locates here. All right, so then what you need to do, you want to find this tail first and then double it, right? So then you still use your z-test statistics, go to the table, and from the table you can directly find the probability to the left again, but now remember we are looking for the tail to the right, right? So then what you need to do, or what is your p-value? Your p-value will be doubles the right tail, right? But this is the left tail, so then 1 minus whatever you found from the table. All right, okay, so that will be the 2 cases for if you have the two-tailed hypothesis. All right, okay, so again, this is the first case when you have the z-test statistics. But remember, in the last step, it is quite possible that you don't know anything about the population. You don't know the sigma, right? So then you need to replace it with the sample standard deviation resulting a t-test statistic. All right, so then if you have a t-test statistic, how you can find the corresponding p-value? All right, so then let's look at the t table, right? And we say the degree of freedom column, and then the top, actually we call it is alpha over 2 in the confidence interval part. But now we are not looking for a confidence interval. So actually the top here is actually our p-value range. So then what do we need to do? First, we need to find our degree of freedom row, which is n-1. All right, so once you find your degree of freedom, you just focus on this row, and within this row, you need to find where is my t-test statistics. It can be between 2 values, right, in this row, and then you just directly go straight up so that you can find the range of your p-value. All right, the good thing is if you have the t-test statistics and you go to the t-table, you only need to care about 2 cases. All right, one case is if you have one-tailed hypothesis, right? So it doesn't matter you have the left tail or right tail, right? So that will be considered as one case. The other one will be two-tailed. All right, okay, so then if you have one-tailed hypothesis, then actually what we do here will be the way how we find the range of your p-value, right? And we did a lot of practice in the in Monday's class, so here I will not repeat that again, right? And then if you have two-tailed hypothesis, you just double it for the 2 sides. And then in your MindStatLab homework, you may have the case that if a exact p-value is needed, right, then you can go through the app, right, and then in the app you have the new, you have the x value, and then to the right you have the probabilities, right? Right, so then if you need the exact p-value, you do need to enter some values in your app, right? So then the new here, you need to enter your degree freedom, and x is where you need to enter your t-test statistics. And then once you click done, the probability will be show up here, which is your p-value. All right, so again, in your MyStatLab homework, it is necessary for you to get the exact p-value, but we know that from the t-table, we can only get the range of the p-value, which is cannot be the answer, right? So here I just give you another option, but of course I need you to practice with this process so that you know how to do it in the exam. All right, so then let's continue, right? So that will be the last step, step 4. All right, so for step 4, we say from the last step, we got